Dear students, welcome back. We were discussing the properties of carbonyl compounds. This is our lecture number 4 in the series. Now, today we will start with chemical properties. And in a series of videos, we will discuss the chemical properties of carbonyl compounds. Myself, Rakesh Singh, Associate Professor in Chemistry, Government Degree College Kathua, UT of Jammu and let us start with chemical properties of aldehydes and ketones. The first one is nucleophilic addition reaction. As I have earlier stated, carbonyl group is polar in nature. Polar nature of carbonyl group is because of large difference in electronegativity of oxygen and carbon. Moreover, there is a pi bond between carbon and oxygen. Pi bond is a big bond. It gets easily displaced towards oxygen, and as a result, oxygen acquire partial negative, carbon acquire partial positive. When we add sodium bisulfite, there is addition, and we get what? Sodium bisulfite addition product. But this is not the final product. If you see, here we have sulfonic acid, here we have sodium salt of alcohol. Now, sodium salt of sulfonic acid is more stable than sodium salt of alcohol. Why? Because SO3 negative ion is more stable. It can do rayonets. Dispersal of negative charge is there in it. Here the negative charge is concentrated on one oxygen. Here the negative charge will get dispersed on 3 oxygen. So this SO3H, sulfonic acid, it form more stable sodium salt. So what will happen? There will be exchange between O negative and SO3 negative. Sodium positive will move here, H positive will go here, and we get the final. This is bisulfite addition. Now, specific examples, if we talk acetaldehyde plus sodium bisulfite. Now you know that sodium is to be given to SO3 negative and H is to be given to what? O negative. यहाँ से आपने देख लिया अब इसको. मैंने इसको इसीलिए 2 स्टेप में लिखा ताकि आपको बेटर अंडरस्टैंडिंग हो सके. Why we have given sodium to SO3 negative, Na positive, and OH. Similarly, if we take acetone, this is acetone. Again, the reaction occurs in the same manner, and we get acetone sodium bisulfite addition. This was addition of sodium bisulfite. Let us move towards next step. Addition of hydrogen cyanide, HCl. Both aldehydes and ketone add one molecule of HCl to form cyanohydrin. Addition product, which we call cyanohydrin. The reaction is usually carried out in presence of base, which act as catalyst. In the absence of catalyst, reaction proceeds extremely slowly. This is the mechanism, cyanide. Now we get this. This oxide ion abstract H positive either from water or from HCN, and the end product is cyanohydrin. Cyanohydrin. There is no negative charge here because when cyanide negative attacks carbon positive, a negative charge gets neutralized. Now this is specific example. We have taken acetaldehyde, we get cyanohydrin. Acetaldehyde we can on acetone. This is reaction with acetone, ACN, we get acetone cyanohydrin. Acetaldehyde cyanohydrin, acetone cyanohydrin. There is another note here. The addition of hydrogen cyanide is initiated by cyanide ion. आपने देखा start किसने किया? Cyanide ion. But HCN is too weak acid to provide enough cyanide ion for the reaction to proceed at a reasonable rate. Cyanohydrins are normally prepared by adding an acid to solution containing carbonyl compound and sodium or potassium cyanide. जो actual reaction है उसमें हम क्या करते हैं? We treat the carbonyl compound with sodium or potassium cyanide in presence of what? Acid. H positive चाहिए ना next step. otherwise तो salt बन जाएगा अगर हम NaCN का इस्तेमाल करें, है ना? तो साइनाइड आयन की कंसंट्रेशन को रीजनेबल लिमिट में रिएक्शन मिक्सचर में रखने के लिए ताकि रिएक्शन रीजनेबल रेट पे चले, What do? We treat the carbonyl compound with sodium or potassium cyanide in presence of acid. This procedure ensures that free cyanide ion is always present in amounts sufficient to increase the rate of. Now next we have addition of Grignard reagent. General reaction बच्चे आपको आना चाहिए. This is the most important reaction. Carbonyl compound plus Grignard reagent. Grignard reagent R is always negative. Or negative, Mg positive. Dry ether is used as solvent. Because Grignard reagent advanced react with water. तो हमें ड्राई ईथर का इस्तेमाल करना है. और नेगेटिव एक्टिंग एज न्यूक्लियोफाइल अटैक ऑन पॉजिटिव कार्बन, displacement of pi bond, and we get addition product or COMgX. And when it is hydrolyzed with water, तो जब हम हाइड्रोलाइज करेंगे वाटर के साथ एसिडिक मीडियम में, what happens? O negative will take up H positive. And what do we get? The final product is alcohol. We get alcohol. If we use formaldehyde, अगर हम formaldehyde का इस्तेमाल करेंगे, we get primary alcohol. If we use acetaldehyde, aldehyde other than formaldehyde, say acetaldehyde, then we get secondary alcohol. Secondary. And if we use ketone, then we get tertiary. अब हमें क्या मिलेगा? Tertiary. For example, देखिए, addition of Grignard reagent, RMGX to aldehydes and ketones. This is general reaction. RMGX in presence of diethyl ether, we get addition product. This upon acidic hydrolysis give the alcohol. O negative, H positive, we get alcohol. Plus क्या बनेगा? MgX positive and OH negative. OH from there it will come water. H positive release हो जाएगा, मतलब acid ने इसको catalyze किया. For example, if we take formaldehyde, we get primary alcohol. Reaction is obvious. I have explained the mechanism. If we take acetaldehyde, we get secondary alcohol, isopropyl alcohol. If we take acetone, again the same reaction, we get tertiary alcohol. You have to understand the general reaction. Once you understand the general reaction, you can easily write the specific reactions with specific starting compounds like formaldehyde, acetaldehyde, and acetone. This was addition of Grignard reagent. Then addition of alcohols or formation of esters. One of the most useful reaction of aldehydes and ketones involve transformation of initial product of nucleophilic addition to ester or ketone. An example is the acid catalyzed addition of alcohols to aldehyde. The expected product, a hemiester, is not usually isolatable, but reacts with additional mole of the alcohol to give ester. So when we treat the aldehyde with alcohol, it results in formation of hemiester. It is a reaction like that of other addition reactions, nucleophilic addition reactions, which we studied. The first step is similar to that. चाहे addition of HCN की बात करें, चाहे addition of sodium bisulfite की बात करें, चाहे addition of Grignard reagent की बात करें. First step is same. That is, one molecule of alcohol add to the aldehyde. Though alcohol is a big nucleophile, it is not carrying formal negative charge, but it is carrying the lone pair. Lone pair है इसके पास, तो with the help of lone pair attack, the product formed is not stable. अगर आप देखें इसके साथ 2 electronegative atom attached, so it get attacked by another molecule of what? Alcohol. In the same fashion as the first. In the second step, there is substitution, and we get gem dialkoxy compound. Gem dialkoxy. Gem होता है एक ही कार्बन पे दो जब अटैच हो ग्रुप, that is called gem. So it is gem dialkoxy compound and it is called as ester. Gem dialkoxy compound and we call them ester. इस चीज को अपने दिमाग में, when we treat the aldehyde with alcohol, it results in formation of hemiester first, which being unstable react with another molecule of ethyl alcohol to form gem dialkoxy compounds, which are called as esters. In case of aldehydes, the Position of equilibrium is favorable for acetal formation, especially when excess of alcohol is present. However, for most of ketone, the position of equilibrium is unfavorable. इसलिए हमने एल्डिहाइड के साथ दिखाया है. In presence of diacetyl gas, aldehydes react with alcohol in presence of diacetyl to form esters, hem-dialkoxy compounds. First hemiacetal is formed, which being unstable further react with second alcohol molecule to form. याद रखें बच्चे, कीटोन में ये रिएक्शन फेवरेबल नहीं है. उसका रीजन भी है कि कीटोन में तो स्टीरिक इंट्रेंस रहेगा, यहाँ पे आया, और दूसरा यहाँ पे प्रॉब्लम क्या होगा कि यहाँ पे टू अगर अल्काइल ग्रुप होंगे, प्लस सा इफेक्ट और ये वीक न्यूक्लियोफाइल. आपने पढ़ा है कि कीटोन्स आर लेस रिएक्टिव देन व्हाट एल्डिहाइड. दोनों चीजें हैं, एक तो स्टीरिक इंट्रेंस, 4 बिगर ग्रुप्स, बल्कि ग्रुप्स अराउंड कार्बन, जब एस्टर बनेगा तो ये भी है. Next we have, तो इस चीज को याद रखें कि aldehydes when treated with ethyl alcohol, first they form hemiacetal and then they react with another molecule of ethyl alcohol to form acetal. First step is nucleophilic addition and then there is nucleophilic substitution. Nucleophilic addition followed by nucleophilic substitution. Addition of alcohols or formation of esters continued over both aldehydes and ketones. Now this is important. Both aldehydes and ketones react with dihydric alcohol. If we take dihydric alcohol, in presence of PTS, para-toluene sulfonic acid is also dehydrating agent. Reflux किया हमने, boil किया, loss of water. Again we get hem-dialkoxy compound, but in the form of what? Cyclic, in the form of ring, and we call them cyclic esters. Bi-membered ring with 2 oxygen is called dioxolane. तो इसका ये नाम आ गया 2 मिथाइल 1,3. नंबरिंग आपने करनी ऑक्सीजन से 1 2 3 1 3 डाई ऑक्सालेट. तो अगर हम लेते हैं कीटोन एसीटोन, if we take acetone, in the second example I have taken acetone and treated with ethylene glycol, we get again gem dialkoxy compound in the form of ring, जिनको हम oxalane कहते हैं. Because we are taking the ketone, so it is called ketone. Aldehyde we call acetal, ketone we call. तो जो याद रखिए बच्चे कि जो डाइहाइड्रिक अल्कोहल है, they react with both aldehyde as well as ketone. तो दोनों से react in presence of PTS, para-toluene sulfonic acid, as well as we are refluxing. The position of equilibrium is made more favorable by removing water. तभी हमने PTS यूज किया, formed in the reaction by azeotropic distillation with benzene or toluene. एजोट्रॉपिक डिस्टिलेशन हम करेंगे जिससे हम वाटर को साथ साथ में रिमूव भी करते हैं. डिहाइड्रेट पीटीएस कर देगा और डिस्टिलेशन से हम उसको साथ साथ में बाहर भी निकालते जाएंगे. सो इक्विलिब्रियम इज मेड मोर फेवरेबल. अगर वाटर रहेगा तो बैक जाने के चांसेस रहेंगे. वाटर इसके ऊपर अटैक कर देगा, बैक जाने के चांसेस. लॉस ऑफ वाटर हुआ, इट कैन शिफ्ट द इक्विलिब्रियम बैक. दैट इज रिमूव्ड बाय एजोट्रॉपिक डिस्टिलेशन. Was about what? Formation of esters and ketones, that is reaction with alcohols. First monohydric alcohol, then with dihydric alcohol. Now we have nucleophilic addition reactions followed by elimination of molecule of water. Nucleophilic addition followed by elimination of molecule of water. तो इसमें सबसे इंपॉर्टेंट जो आते हैं बच्चे, वो आते हैं रिएक्शन विद अमोनिया डेरिवेटिव्स. अमोनिया डेरिवेटिव जनरल मैकेनिज्म आपने अंडरस्टैंड करना है. रेस्ट ऑफ द रिएक्शन विल बी वेरी इजी फॉर you just understand the general mechanism. So we take the carbonyl compound treated with ammonia derivative. NH2G. What is G? G may be OH, hydroxylamine. NH2 hydrazine. NHC6H5 phenyl hydrazine. G is a group like this. ये यहाँ पे दिए हुए. NH2 will attack on the carbonyl carbon. Why? Because it is carrying partial positive charge and oxygen carrying partial negative. You get this? Now, आपने बच्चे पढ़ा हुआ है, जैसे इस चीज को आप दिमाग में रखे होंगे कि जब एक कार्बन से एक साथ OH अटैच हो जाए, there is loss of one OH makes the other OH unstable by minus I effect. Same situation is here. Instead of OH we have NH. So again there is loss of one, catalyzed by acid. loss of water catalyzed by acid, and we get final product. So nucleophilic addition followed by elimination of molecule of water. C double bond O get replaced by C double bond N. C double bond O को रिप्लेस किया बच्चे हमने किससे? C double bond N से. बड़ी G मैंने यहाँ लिखा हुआ है. अगर GOH हो, it is called hydroxylamine. NH2 hydrazine, NHC से phenyl hydrazine, NHCONH2 semi carbazide. One by one इनको देखेंगे. These reactions we will study one by. Next, जो reactions जनरल मैकेनिज्म हमने स्टडी कर लिया, जो रेस्ट ऑफ रिएक्शंस है दैट वी विल कंटिन्यू इन आवर नेक्स्ट वीडियो लेक्चर. माय व्हाट्सएप नंबर, you if for any doubt, any query, you can WhatsApp me regarding this. Thank you very much.